Okay, so we have a kind of simple topic. What is 3D? Means I have a mango in my hand. So this is 3D. Okay. So if I have a hand and it is in XY plane and this is Z axis, XY plane, this is Z axis, then XY plane is 2D. So what is a graph? What is a wireframe? What is a surface? What is a cross section? What is a contour? And what is partial derivative? Okay, these are the terms generally we hear in 3D. So suppose this is XY plane. So this mango is kept in XY plane, uh, cuts this mango. So I can keep this mango like this. So XY plane cuts this mango. Now, if this is XY plane, this is X, this is Y, positive direction, then up is Z. Okay. Now I have Z equal to fxy. So there is a function where the independent variables are X and Y and it leads to a value. So if I talk like this, then okay, so there is a plane xy. So at each xy in the plane, there is a z value. So whatever we see now, these are nothing but the z value. Z value is nothing but function over x and y. Okay. So if there is a function over x and y, which variation of x and y function value varies. I mean z varies. I mean height varies. So if x and y are in one plane and as per their value, so if I take xy as 2, 3, xy as minus 2, 3, xy like this, or if I normalize it to 1, 1 maximum and then if I take zero point 0.5, zero point 0.7, then based upon the fxy, so fxy is the equation that is based upon x and y and that will lead to a certain value called z. So if z, so if I see this and if xy crosses it and center is at the middle, then at center it is at maximum height. So at 0, 0 fxy, if I set x equal to 0 and y equal to 0, then z is maximum. Now if I move along x-axis, keeping y 0, then here at x-axis at some point z is 0. Similarly, this side at x 0 and y something, z is 0. But if I start moving the y, I start moving the kind of, so if I'm moving like this, then y is decreasing, x is constant, and z is increasing. I mean, I think it is understood now that with the variation in x and y, fxy varies, fxy is nothing but z, so height varies every point. So we call it 3D. So 3D is nothing but when x-axis and y-axis they lie in a plane and if they vary then function over it value also vary and that is nothing but the height. So based upon the xy height vary. So this is z equal to fxy equal to function over x and y is nothing but 3D. This is what we talk about 3D. Now, if I take some points, okay, so uh, at some xy, I take z, another xy, I take z, okay. So typically on the kind of outside, if I take few points, then I connect it, it becomes a wireframe. So we call it wireframe. Means if I connect a few points, it becomes a wireframe through line. If I make a hypothetical surface over the lines, then it becomes a surface. Wireframe surface. Okay. Now, uh, if I draw kind of analog x and y, it's not digital x and y. If x is zero point 0.1, y is zero point 0.1, it's completely okay. Whatever shape we are seeing, this is called graph. Wireframe point by point. If we kind of simulate it point by point, that is wireframe, and if we connect all the lines and make a surface, that is surface. And if we really draw it with all the granularity, kind of continuous, then it becomes a graph. If I cut the graph with something constant, like in this direction, y is constant, this is x-axis, y is constant. This direction, this is y-axis, x is constant. So along x constant, if I cut this, okay, so that is called cross section. If I along y-axis constant, so this is y-axis, okay, so this is x-axis, okay. So along kind of along this is z-axis constant. So this is a kind of if I sorry, if I cut like this, then x-axis constant. If I cut like this, then y-axis constant. So if I cut graph like this, keeping one axis constant, then it becomes a cross section. If I cut this, keeping z as constant, this becomes contour. This is contour. So contour diagram generally we draw for the 3D graphs where at each height what is the xy kind of drawings. So that is contour. So at each z, so z from origin. So if this is xy plane, if I consider origin, then z starts increasing. At each z, if I make a slice, cut or cross section in the 3D, that cross section if I see from the up, whatever the circumference, whatever I see, that is called contour. So at each height we have contours. So contours are important when we draw hilly area, like a hill. So at each level, what is the cross section we see from the top? So this is contour, and this is story of 3D. Okay. Now we'll talk about derivative. Suppose, okay, so if I say derivative in the sense if I have fxy, fxy is a function over x and y. If I differentiate it with x at any point y, okay, fxy is nothing but z. So z equal to fxy. If I say dz by dx, okay, I am trying to get the uh, change in z with one unit change in x. So along the x-axis, if there is one unit change, then at a particular point A or particular point x, how much z would change? With one unit change, unit can be anything. Whatever data is provided tends to zero. That is ideal. Okay, and it should be limitable function. So for one unit of change in x, how much z changes? If it is y direction, for one unit of y change, how much z changes? So dz by dy means how much z changes with one unit of change in y, provided at that moment x is constant. With one unit of change in x, how much z is changing, provided along the x what we are changing, y is constant. So dz by dx provided y is constant, and dz by dy provided x is constant. So this is called partial derivative. fx, f dash x, that is differentiation. So f dash x with x means dz by dx. Okay, so whatever equation we get fxy, we differentiate with dx, considering y as constant. So any point of the y we take. So this is partial derivative of fxy, keeping y as constant. Now dz by dy, then keeping x as constant. This is partial derivative of fxy, okay, with y while x is constant. So these are partial derivative of fxy. Okay. So like if this is a mango and this is x-axis, and we are here. So derivative is nothing but slope. Whatever slope we are seeing here. So with increasing x, okay, if I increase x keeping y as 0 or any constant, z is decreasing because we are at downslope. If we are at this level, then with increasing x, z is increasing. If we are here, then with increasing x, z is decreasing. So partial derivative of fxy, okay, along the positive x is negative because slope is down. Whereas this side, where x is negative, okay, partial derivative of x fxy is positive. So dz by dx is positive on this side because z is increasing if x is increasing. If there is change in x, then dz by dx increases while we keep y equal to 0 or any constant. So that we have to see. So like here, this side, this is y axis, then dz by dy, okay, if I see that it is negative of my side, dz by dy is positive. So we talked about wireframe, surface, graph, cross section, then contour, then 3D, then derivative nothing but slope, then partial derivative in the sense that fxy function, we do the differentiation with respect to either x or y, keeping other as constant. So this shows the change in the height with change in the x. Okay, how if I change x 1 unit, how much unit height changes? So that is dz by dx, that is fx. So we denote f denominator x xy. So fx xy, okay, fy xy, keeping other as constant. So how much z changes? So this is the kind of. So later on we'll see on the these analogies. So very precious analogy, multivariable multivariate analysis. As per we move on to more in the differentiation differential equation, and then vectors, then dot product and cross product of the vector. So that will see.